Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to kind of extend our Taylor series discussion to look at graphs so that we can compare some of our various solutions that we had come up with. And to do that, we're going to need to enter things as an array. But just as a reminder, first thing we want to do is, if we're trying to do Taylor series, is we need to let it know we're doing it symbolically and that my variable I'm using is x. And so I start with sims space x. And then the function, we'll do the one that is actually done by the help because actually it gives better graphs than the one I was planning to do. So I liked their choice better. So my function is sine of x over x. Now, as a reminder, that little repeat after me thing is annoying, so I might choose to put a semicolon at the end so I don't have to look at this. And so let's do Taylor 6 is going to be a Taylor expansion of the function f with order 6. Okay, so that's going to be my highest order term. And I don't really want to see it, so I'll do that. Taylor 8 equals Taylor f order 8. And again, don't really want to look at that. So Taylor 10 equals Taylor f order 10. So I have my three functions in there. If you did want to look at any of those, remember one of my options on this is that I can use the pretty function. So pretty of Taylor 6. We'll just look at that one. And it is in fact giving me up through not including the sixth order term in that polynomial. Okay, so I have these various expressions that are approximations to sine of x over x. If I wanted to do a graph of these, then I want to plot multiple functions. So fplot, open parenthesis, but I want it to be an array. So I want the function f, Taylor 6, Taylor 8, and Taylor 10 all plotted against the function x. So fplot, let's see, open, because remember I'm doing an array now. And so Taylor 6, Taylor 8, Taylor 10, and f. And that's my list of functions. So those are all together in a row. Close the parenthesis. I can tell it. If I don't like that, I could modify x limits. So xlim -4 to 4. They gave us -5 to 5, right? Xlim parenthesis -4 to 4. There we go. And you'll see that it's changed the limits there. If I want to turn the grid on, now it has grid markings, which make it, easier to read. I can add a legend. So if I want to add a legend, sixth order, I want to make sure that these match up with the same order I did up there. Eighth order. Now these are separated by commas because they're going to go on different lines in the legend. And I don't know, you can kind of do whatever you want to. You can add all sorts of things, but this did give me a legend. You can have it make choices about where to put it, or you can specify where to put the legend. There's a lot more you can do with graphs. But let's go back to the Taylor series concept for a moment. Because what I have here is that my original function is this, well, let's see. I don't even see my original. But this is my various terms here. This one has to be my original. But they are up in this region, very, very close. But as you get away from the expansion point, the approximations get rough. And they're not coming back in and matching the shape of the original function, which is, I guess, this one right here. Okay? And the variability is, it varies. Anyway, so that's kind of a real quick look at doing graphs. We'll be using graphs more as the course moves on, but this is just to give you an introduction to this. One more thing though before we go. I want to show you how to clear your screen. Maybe you're wanting to start a new problem, or this was just garbage. I can clear, say, just one variable, so Taylor 10, okay? And if I look over here, Taylor 10 disappeared from the list. I can also clear everything. All variables disappeared. But I still have this mess here. If I want to get rid of that, I want to clear the command window, and that's CLC, which should be easy for those of us at Missouri S&T to remember. So CLC clears the command window. So that concludes this little video lesson. When we come back, we'll be looking at materials for solving nonlinear equations, different ways that we can do that in MATLAB. Thank you very much for your time.